I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
Sound level.
Nothing the water level device isn't designed to form a level line. It is designed to form a horizontal plane of reference. You don't believe me? Don't believe me? Read the definition.
So Panda, have you come in here for a reason? What?
I said that
Actually, I remember it was you who invited me to join the Discord through Twitter.
Oh, I put the link out. Yeah. I do that every now and again. Did I specifically ask you to join?
I recall you were searching for someone who, well, I don't remember exactly how our conversation went, but I told you that I was a mathematics teacher in high school, and you needed me for something I don't remember what.
I asked if there's anybody that could explain the practical use of geometry.
Oh.
And you said yes, a mathematics teacher would be able to do that.
Yeah. Well, practical use of mathematics. Which part of mathematics?
Geometry.
Geometry. Oh.
See, well, because the whole debate or the discussion we're having with people is vertical and horizontal. Are they practical uses or practical terms for the reality use of geometry, right?
Yeah, I think I understand what you are talking about. That's not a surprise to you, maybe, but I get that question a lot.
Oh, do you?
Actually, you have no idea. Every time I start a new year and I get new students, and first lesson I let them ask any question they want, and almost 100% I get the question. Well, how will knowing Pythagorean theorem or Thales theorem be of any use in our lives? And yeah, I get that question a lot, and I always answer the same thing. It's very simple. It's no use. It's no use in practical lives unless.
Sorry, do you say the Pythagorean theorem is of no use?
No, I didn't say that.
Oh.
I said when my students ask me what will be the use of the Pythagorean theorem or Thales or trigonometry in their lives, generally I always answer them, it won't be of any use to them because majoritarily the job they're aiming to do not involve the use of geometry.
Whoa.
But
are you a mathematics teacher, do you say?
Yes, I am.
So is that how you inspire your students?
Oh, well, generally they get a lot of surprise from my answer, and quite surprisingly, they're getting a lot more attention about what I'm saying than my other colleagues, which I asked my colleagues how it happened, how they did in their classes, and Apparently, I'm the one that gets the most attention from my students, especially because I have, we could say, unorthodox method.
Sweet,
Like
I'm
that.
all up for that.
Like saying it won't be of any use instead except if you're a carpenter or an architect or I don't know a mason
Surveyor, maybe?
a surveyor, yes, of course.
Yeah.
Of course, it's very useful when you have a surveyor, but when you're an accountant,
Do you
I don't
know?
think so.
Do you know what the etymology of the word geometry is? Have you-
Uh, I knew it, but I think I forgot.
Geo is earth,
Yeah,
and
and
metra is measurement.
oh yeah, thank you.
So
Thank you, I remember.
yeah.
Yes, indeed, indeed.
So that was basically what we were saying, was that who considers themselves able to talk about the practical use of geometry, and you stood up and you said I can.
But yes, because I honestly don't know how when one of my students is aiming to be what's the English word for it? When my students are aiming to be caretakers, I honestly don't know what use they have in their lives for Pythagore.
Really?
I'm being totally honest with them.
Wow.
I say to them, yes, I'll teach you that, but
How
I
long have
don't
you been
know.
a teacher for?
It would be 5 years.
And your background, was that from mathematics through the college and university structure?
Not quite actually. Actually, what I went through was, I'd say, general high school with scientific tendency. Then I had a degree in physics and chemistry, and then what's the word? I always forget. Um, the diploma that's between a degree and a doctorate. I always forget.
Okay.
Masters.
Thank you. Then after I got my degree, I went for a
What was
master's
what was the
in
degree
teaching,
in?
physics and chemistry.
Okay.
So totally not mathematics. Then I went for a master's in teaching, actually, because I don't know if that's the case in the United Kingdom, but in France, the
Yeah. The teaching is a
the
completely separate thing, other than they still teach you how to teach, don't they?
yeah
Yeah.
yeah
A
and
teacher training college, we call
Yeah.
it over here.
yeah, that's that. And in France, you have to go to get a master's in order to teach.
Yeah.
In order
Yeah.
to teach, and when then after I got my master's, I was teaching, and I chose to be. I chose initially. I wanted to be a physics and chemistry teacher in general high school, but I I discovered the world of technical high school, and after I saw it, I said to me, "Whoa, actually, that's more interesting and more it's more close to reality than general high school, where the teachings are basically in the theoric world."
Okay. Well, so when you said that you could do geometry, you've never really had any formal training in geometry.
Hmm?
Do you?
No, I didn't. Apart from my high school years, of course.
Okay, yeah, but that's not really any geometry. I say that because when I asked you what the practical use of geometry could be, you said that it wouldn't ever be of any use to any of them. Well,
Oh, yes, but I did say that that's because what they're aiming to be does not involve the use of geometry.
well, see,
When-
that's where
when
I
have-
would have to disagree with you there, because geometry teaches you a
Is it?
logical process and how to gain proofs from such a process.
then
So
allow me to
I
say-
would say personally it is vital in the understanding of especially young minds to be able to
understand what you're
formulate a
saying.
logical statement and come up with a proof. Geometry just shows that in the most practical way possible.
I know exactly what you're saying, and you will be very surprised, but I do teach the scientific method to my students.
It's nothing to do with the scientific method.
Actually, what you're saying resembles. It looks a lot like what we could call the scientific method.
Yeah, but
In,
if you simplify that,
experimenting,
yeah, no, if
in
you
having
simplify it,
logical conclusions.
yeah.
Simplify.
Simplify the scientific method is logic. It's just a
Yes.
different way. You change cause and effect
Yes, totally.
into antecedent consequent relationship. It's basic logic, right? But the geometry
Yes, totally.
geometry is the proof part of logic. It is the logic that cannot be denied.
I think I understand what you're. I think I understand your point.
Yeah. So
Yeah,
I
you
would
could
just
say,
say
you could say that.
it's a lot more useful than you seem to think it is.
Oh no! Please don't make me say what I didn't say.
No,
I
I'm
don't
yeah,
say-
no. I'm just saying.
I
I
don't
think
say-
you underestimate.
Oh no, totally not. Actually, I know geometry is very useful in our everyday lives because without geometry, how could we ever build anything?
Well,
Yeah.
it doesn't seem like you have much of an opinion of your students then, because if you're telling us now that you think geometry is useful in everyday life, and yet you're telling your students that geometry will never be useful to them in their everyday lives, you don't have a very high opinion of your students.
I don't know. I think I wasn't clear enough. Maybe I didn't use the right words. I don't know. Actually, what I'm saying is, regarding my students, when they ask me, how will knowing geometry be any useful? Knowing the geometry theorems, trigonometry, etc.
No. That's
Yes, I know,
different.
but I said
They're not theories,
no theorems.
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 No,
Excuse me.
you see, I think you're
Excuse me,
getting it
I'm
wrong.
not,
Your Pythagorean
not
theorem is a proposition within Euclidean geometry, right? It's number 47, book 1. It's just a part of it. The process of geometry, not trigonometry, it is a logical process that you put your mind through.
Yes, indeed.
But
I do not deny that.
what we invited you here for, or what you invited yourself, you said you could help us talk about the practical use of geometry.
Yes.
Right. Well, where we initially went and started off at the beginning was that the geometric process of Pythagorean theorem and all of that sort of right angled triangles, parallel lines, all of that is a use of the reality, which is Earth measurement, right? So in reality, what we have is a vertical and a horizontal.
Yeah.
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 Now, the vertical and the horizontal are geometrically called a perpendicular.
Yeah.
So that means there are 90 degrees in between the lines. That, you know, perpendicular is a relationship of one line to the other, expressed in geometry, right? It, you know, the geometry is where the rules are laid down, but in the practical application of it, we deal with a vertical and a horizontal, right?
Generally speaking, yeah.
Yeah. So when you're talking about the reality use of anything, whenever you talk about a straight line or a distance travelled or whatever, and you were to transpose that into some sort of a drawing, you would transpose it as a you know, like a geometrical drawing, right? A plan.
Yeah.
Of anything, but you would always use the vertical and the horizontal as your reference frames. You know, for like within maths, you draw graphs off it. You have an x and a y on a graph, and then if you transpose that into Cartesian coordinates, there are x and a y and a z. Right? They're all straight lines, aren't they?
Yeah.
Yeah. So, can you explain why some people think that that straight line bends? You know, there's a lot of people that...
okay, you're talking about the Earth's curvature, aren't you?
the Earth curvature.
Yeah.
Where's that? I mean,
that's what you're talking about.
you mean topography?
Yeah.
Yeah. Yeah. Well, topography
That's what
would...
I'm talking about.
Yeah, we say here that you cannot measure a curvature, because you're only measuring a point to a point. You know, you're always measuring linear points, so that you can only ever plot that point to a point, which would be a straight line measurement. So you could maybe be able to plot a curve, but I mean, it wouldn't ever actually be a curve because you'd just be joining up point to point, even when you were drawing it or whatever. Even when you're measuring it with out in the land. So when you set up a level or auto level or a theodolite, then you set that up to be horizontal, and all of the measurements you take are a vertical height difference from the land underneath. So the horizontal becomes the reference frame, and the measurement becomes a point distance of the land below that thing, right? So that's how you measure the rise and fall, the tilt to the elevation change above a horizontal reference frame. But that's on the land, right? So you can't measure a curvature there. And the water level is a tool for establishing a horizontal plane of reference as well.
Actually, I don't think so.
Well, no, it is. It's a tool. That's what it's used for, right? You just get you say you've done physics. You fill a tube up with water, and it will equalize across both ends. The line across the two of them would be considered horizontal, right?
Between the two extremities, yeah. But you have no means to verify if the surface of the water inside your tube is actually following the straight line you're drawing between both ends.
Yeah, because
Don't you?
you just put the water level at the bit that you want to check. Put it in the middle, put it at the end, put it halfway along each end. It doesn't really matter. It would still be on the same horizontal, wouldn't it?
Actually, I think that's where we both disagree.
Okay, so but you would agree that the tool, the auto level, as you're looking through that, that is a horizontal.
I would agree. I'm agreeing it's a horizontal when you're drawing a straight line between both extremities. But
You're looking through a crosshair.
what?
When
I
you
don't
when you sight through
actually.
an auto level, you're looking through a crosshair.
I know, but actually I don't know if between both points the surface is actually following the straight line.
No, the tool establishes the horizontal. The surface of what's underneath
Okay.
can
I think I didn't understand very well what you say. Sorry.
yeah, the auto level, the tool establishes the horizontal, right?
Yeah. Oh, you mean the? Oh, okay. Sorry. Okay. The level tool. You're talking about the level tool. Okay. Well, actually, the level tool is it's very peculiar because it serves as both an indicator of vertical and the horizontal.
Not the water level. No.
I'm talking about the tool, you know,
Yeah.
the tool, the spirit level.
No. Yeah.
I
That
think
is
I think
only
we
well. That's
both.
like the builder's level, right? That's not an auto level, and it's not a water level. There's a few different types of level, right? But basically,
Yes.
what we come down to is the word level. That means
Yes.
horizontal, doesn't it?
No.
Do you not think level means horizontal?
No, and I can explain you why.
Okay.
It's very simple, actually. Take
Can I?
a ball.
You are a teacher, really, aren't you? You're not.
Yes, I am.
Okay.
Yes, I am. Take let's say a ping pong ball.
Take a
No,
ball.
even better, a billiard ball.
Okay.
If you take a billiard ball, the surface of the billiard ball is
You mean the
level.
table it's on, the slate?
No,
When
I'm talking
it's
about
level to that table, it's flat. Proper flat, two-dimensional surface, horizontal.
and
Otherwise, the ball rolls into a corner or to the side or something, right?
I'm not talking about the table. I'm talking about the ball.
Oh well, we are talking about level.
Yes, and
Well,
I am
that
talking
surely
about
that's
level.
the table that's level, not the ball.
Then I'll finish, and you will understand what I mean.
Okay.
The ball is this, the surface of the ball, of the billiard ball, is level in relation to its center.
Okay. I'm not so sure you've got the correct understanding of the word level. Have you ever used a level?
No, because I'm not a topographer.
Okay, but you know what, like you just said it before, a spirit level.
Yeah.
You know what that is. It's like a big stick, isn't it?
Yes, I do.
So where's that
Yes.
level to then? In that relation that you've just told us about, what you think level is on a ball.
Well,
Where's the level
I'll,
that the level
okay.
is?
Okay. I'll say it in in a broader sense. What I call level is a line that's following a surface, whatever the surface is, at an equal distance for the whole length of the line.
Well, you did physics. I mean, that's not what water does, is it? Doesn't say level with the what's underneath it.
Actually, I think it does.
No, it doesn't. You know, it conforms to the container it's in to leave a level surface on top.
No,
Yeah,
the
yeah, of course it
surface-
does.
The surface of the water follows.
You can't
the-
drop a cube in a glass of water and get the cube to stay on the top because the water is conforming to the surface below it, can you? Doesn't work like that. That's not how water works. Water leaves a horizontal surface
What makes you think water doesn't work like that, actually?
because it doesn't. I know, I've used it practically. A water level, and level means horizontal. It doesn't mean conforming to the surface.
Can I just get a question here
No,
from
I
Panda?
didn't say level is conforming to the surface. That's not what I said. What I said
You
is-
went to a billiard ball to explain level.
Yeah, the billiard ball, the surface of the billiard ball is indeed level in relation to center of the ball. Because when you're looking at a billiard ball, the whole surface is at an equal distance of the center.
What do you have that tells you that? Who is your
Hang on, Bev,
source?
Bev,
Sorry.
Can I just get a question here?
Yeah, go on.
Yes,
Right.
we do.
Panda, right?
Yeah,
I put a shelf up in my house. I use a
Yeah.
level to get it level.
Yeah.
So you're telling me that the each end of that shelf is level with the floor. Yeah?
What you're using a spirit level to get it level.
No, it doesn't matter. We're just talking about the word level.
Yeah.
Doesn't matter what
Yeah.
I've used to get it level. We're just talking about the definition of the word level and how you use it.
Yeah, could you measure up from each edge of the floor?
Well, if you
Hang on, Bev. Right, so you are telling me that
Yeah.
that is level with the floor.
Well,
Yeah.
if the whole length of your shelf remains at the exact same distance from the floor through the whole length of your shelf is indeed level with your floor.
But the floor might not be level. I might live in a 15th century cottage and it slopes to one side, but the shelf is still level according to the level.
Well, something is always level in relation to something. It has to be. You can't have something
Okay,
that's
so
just level.
my floor isn't level, but my shelf is level. What is my shelf level in relation to?
Excuse me, can you repeat?
The floor isn't level. The shelf that I've just put up, right?
Yeah.
We've established that the floor is. I live in a 15th century cottage,
Yeah.
an old French farm cottage, let's say, out in the middle of nowhere, right? The floor is no longer level,
Yeah.
but the shelf is level according to my level.
Yeah.
So what is my shelf level with?
I would say the center of mass of the Earth.
Right, okay. Now, if you take a line from each end of my shelf is a mile long, by the way,
Okay.
right? You take a line from each end of this shelf to the
Yeah.
center of your Earth.
Yeah.
My shelf should then have an 8-inch curve in it,
No.
according to your bull maths, because it's level
No.
with the center of your your Earth. How can each end
No.
of a straight line shelf have
No,
an
no,
8-inch
no,
curve
no,
in
no,
it?
no. Okay, stop. Forget the 8 inches per mile squared rule. Forget it. It's
So you've got
false.
no curve then?
It's completely, literally false.
So you've got no curve.
That's not what I'm saying.
So what should be the curve in my shelf over a mile according to you then?
Over a mile. How could I say it? I can try to calculate it if you want. Sorry for the noise. Let's say. How can I say it? I had the formula ruled out. I can calculate it.
No,
Actually,
so you can't measure it.
Yeah. Do you know if anyone has measured it?
no, that's not what I said. I didn't say I can't measure it.
Oh.
I said I'm trying to find the formula.
Yeah, the
That's
formula
correct.
is a calculation.
Yeah. He's a
Yes, it's a
mathematician. He knows
calculation.
that. He knows.
You can, excuse me, French speaking. You can actually calculate the curvature, but it depends on what you're trying to calculate. What are you trying to calculate here? Are you trying to calculate the
We're
drop?
trying to measure geometry. Right.
Okay.
The practical use of
Okay.
the
Are you
geometry.
Okay. What are you trying exactly to measure? Are you trying to measure the drop?
Well, listen, we're not going to get into our test or anything yet. We're just trying to establish
No.
the basics of
I'm
what
trying to clarify.
what you imagine that you're talking about first.
Yes, what I'm trying to say is I'm trying to clarify what we're talking about because it's not completely clear to me.
Okay, right. Well, the practical use of
Yes.
geometry, right, is Earth measurement. That is the practical use of geometry.
Yes.
Right
that's
now,
what
so okay, so what we
what
do
geodesists
is
do.
we establish a base, a first principles, let's call it. Now, first principles within geometry would be horizontal and vertical. Would you agree? The practical use of geometry.
Yeah, totally.
So, because you
Yes.
need those two as your reference frames in order to measure
Yes.
anything from.
Yes.
Okay. Now, when we say, let's say a plumb bob, you know, like you've done physics.
Yeah, plumb line. Yeah.
Yeah. Right. Well, that is a vertical.
Totally.
Yeah. And the perpendicular to the vertical is a horizontal, and that is established by a level. They're the two practical tools that we have, and they are both independent of each other, and both used practically all over the world, all over everywhere, right?
Yes.
For
Yes.
centuries, millennia, for whatever you call
actually
time,
agree.
right?
Yes, we
So,
actually agree.
okay, so they're the two tools that you can use, the level and the plumb. And you can measure angles and you can measure distances from each of them. Now, if you are doing that, then elevation is a change from average or mean sea level across the land. It's a measurement where it rises from that mean sea level. That's your datum.
Yeah.
Right, okay. So
Yeah.
so that's your starting horizontal. And you measure the elevation rise over distance, and you plot that in a map to make a topography model of the elevation of the land above that water level.
Yeah.
Yeah. Well, if the water level is the horizontal that you use, then why do you imagine a curvature?
Okay. I think I understand better now. So, what makes you think? No, I'll say it in another way. The water level. When you in your demonstration, you didn't say the water was a horizontal reference
Yeah, it's the level.
until the end. Yes, it's level, but level, as I said before, doesn't mean horizontal.
Yes, that's what you said. A vertical is established by a plumb bob, the practical
Yes.
tool, and a horizontal is
It's
established by a
perpendicular
level.
to that. Actually, no. A level shows the same thing as the plumb line.
No, it
It
doesn't.
shows. See,
No,
yes,
it
does.
shows it's
No,
perpendicular.
it shows the perpendicular to the vertical,
Yes, which is a horizontal.
which is a horizontal.
Yeah.
But, as I said, horizontal doesn't equals level, unless your reference is horizontal.
Yeah, that's what the tool establishes, right? The tool establishes a horizontal frame of
Yes,
reference.
yes, totally. It establishes a horizontal reference,
Yeah.
but it
But-
doesn't mean that the ground you're on or the water is level in relation to that horizontal plane.
Yeah, it establishes.
created
If you
with-
ever seen a water level, do you know what one is?
Yes, I do.
Okay, so why do you keep seeming to confuse it with something else?
I'm not trying to confuse anything. I think we are not using the same words or the same definitions for the words.
Which chat can you see? Let me
I don't think we're using the exact same definitions.
debate discussion. Can you see that chat?
Yes.
Let me get.
Um,
I will show you a water level as I understand it. The tool.
When you mean
Okay.
what the tool?
Yeah, a water level
Yes.
device.
Yes, that's exactly what I pictured in my head.
Okay. Well, if you read it, it says
Yes,
a water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference.
Exactly.
Well, that says horizontal plane.
Yes. Okay.
Okay, you said you know geometry.
Okay, rethinking about what we've said until now, I understand better what you say. Okay. But I stick to what I said. When, let's say, a lake, the water surface of a lake is indeed level, but not horizontal.
Okay.
Actually,
Do you want to
that
go
too
to a
is
canal?
actually-
Do you want to imagine a canal, right? Because that's just a big
Yeah, a
trough
canal.
of water.
Yes.
Okay, so let's imagine a canal with in between locks, and let's imagine it's above a mile.
Yeah.
Okay, so let's use that as the water that we're talking about.
Yeah.
Okay, now, would you not say that that is horizontal?
No.
Because, you know, like at one end of it, it will be the same elevation, won't it?
Yes, it will be the same elevation.
All the way along.
But what is the elevation? I'm trying to find my words.
Do you want to have another one and then go?
How was the elevation determined?
Because of the level of the water, right? The water level established a horizontal, and that horizontal means it stays at the same level. So therefore, it's the same level at one end as it is at the other. The level, horizontal plane, is transferred from one end to the other.
And okay, and that's where we are actually disagreeing.
Okay, right. Well, because since you do geometry, right, let's go to one
Yes.
end of the canal, right?
Yeah.
And we will drop a plumb bob to the water surface. Now,
Yeah.
the plumb bob is a vertical,
Yes.
and the water surface, would that be horizontal? Would it hit the water surface perpendicularly?
The water surface will be horizontal just under the plumb line.
Okay. But you, like,
No-
you say
nowhere.
you are a geometry teacher, right? A horizontal is a straight line.
Yes, indeed.
Okay. Now, you do use Euclidean geometry, right?
What? I don't think I understood your last words.
You don't. You do use Euclidean geometry.
Yes.
Right, so there's a straight line. So a horizontal is a straight line, and straight lines can be extended. A terminated straight line can be extended indefinitely in a straight line. Right, so
Yes,
you saying
yes,
at a
infinite
little
line,
bit
yes.
of a line, it doesn't really count because the horizontal is extended all the way. Right, because at the other end of the canal, you could do the same and drop the water level.
Yes.
Right, so, and you could do it all of the way along that canal surface, couldn't you?
Yes.
And it would be horizontal all the way along, wouldn't it?
Just-
So it would be a series of horizontal lines all connected together from one end to the other.
No, because
No?
it wouldn't. I
Well,
say
where wouldn't it be horizontal then?
because you are assuming from the start that the ground is horizontal.
It's water level. That's what we're doing. We're talking about the water level. Like we said, the
Yes.
water level doesn't matter what the surface is underneath it, does it? The water level will remain the same elevation all the way along it, won't it?
Yes, it
Mhm.
will. What I'm saying is, and it comes around what I said earlier about level. Level doesn't mean horizontal.
It does, though.
No,
Yes, it does.
totally not. These aren't synonyms.
Have
Can
you-
I just point you back to the definition of water level that Bev dropped in the chat just now? Can I get you to read that out, Panda?
Okay, let's get back to it. So, water level, the tool water level, indeed can show us horizontal. I don't deny that. We agree on this.
Right, so that is a definition of the word level being used as a tool.
Yeah.
So they are
But-
defining the tool of a level as giving you a horizontal.
Well, the tool in the Wikipedia page, yes, indeed can show us horizontal, but a water surface, say a mile long, or even longer if you will, isn't necessarily horizontal.
That
It
is a water surface.
It is level.
The
It
water
is
level is giving you a horizontal water surface.
yes.
So
With
you've just contradicted yourself.
no, I'm finish. Okay, comprise two different surfaces.
On one plane.
The tool here is comprised of two different surfaces, one in each tube.
But they're
No.
on the same plane.
I thought you did physics.
No, they aren't.
They're connected.
Yes,
They are... Ah, no.
they
Okay,
have
let
to
me-
be on the same plane.
Stop. I'm trying to concentrate to not
No.
be equivocal when I talk. They aren't exactly as 100% on the same plane.
They have to
However-
be on the same plane.
However,
If you hold them
however-
6 inches apart, they form a plane. If you hold them 6 foot apart, they form a plane. If you hold them 100
However-
meters apart, it is the same plane.
however, the difference is so ridiculously small.
The difference of
8 inches
what?
at a mile.
No, wait a minute. The difference of what?
Okay.
Please, please
let's
state.
start-
Don't say the difference is so small. The difference of what, please?
Okay, let's stop geometrically speaking. Do you know what a tangent is?
Of course,
Oh,
it is a
boy.
straight line that touches.
That
If you want
touches
touching, he's
only
here. He's here
one
for
point.
you. Yeah. At one point only.
Tangent, 1 point only.
Yep.
A horizontal plane
Pardon?
on the horizontal plane
Yeah.
that goes
Yeah.
over the surface of the water in the first tube is tangent to the water surface inside that tube. Do we
What?
agree?
Where did you
What?
where did you get a tangent from?
He's
We're
throwing
talking
a
about
tangent
geometry.
off the water level in one end of the tube, I believe.
Where did you get a tangent from? That just magically appeared from nowhere.
Yeah, it's from the in
Actually,
the end
no.
of the water tube.
Actually, no.
We're talking about geometry. We're not talking about
Yes.
putting tangents against circles.
Tangent is geometry. Let me finish, please.
Yeah.
Yeah, but
Okay.
your tangent magically appeared from nowhere.
I know, that's why I will explain why I'm talking about the tangent. And
Okay.
sorry, it did come out of nowhere. It did came out of nowhere. Do we agree that whenever you're using a plumb line, you have a vertical? Do we agree on this? Yeah, I know, but it will appear, it will be more clear when I will finish. Do we agree?
A plumb line gives you a vertical. Yes, I think we
Okay,
can agree with
that's
that. Come,
all
we
we
can
get
agree.
from a plumb line. We get a vertical. Okay. Do we agree?
That's a
That-
guaranteed straight line, that, right? It's definitely a
Do
straight
we-
line.
Do we agree that
Hang on. Bev's
The
asked you a
what-
question.
Yeah.
That is a straight line, definitely a straight line, and a straight line can be extended indefinitely according to Euclid's definition. And you have
Yes.
agreed that you use Euclid's geometry teaching to your children.
Yes,
Mhm.
and
Yeah.
we're talking about the vertical here.
Yeah,
Brilliant.
but we're defining that straight line of a vertical. Yeah, that vertical forms an indefinite straight line according to the definition given by Euclid. Yes,
Totally.
Brilliant.
totally.
Yeah.
Can I finish?
Yep.
On you
It's a
go.
good one.
Okay. Do we agree that the water surface is just under the plumb line, perpendicular to the vertical?
Absolutely. We love that geometrical term, perpendicular. It's one of
I
our
do-
favourites.
I do
Perpendicular.
insist on just under the plumb line.
But that perpendicular, yeah, because the vertical is a straight line, so therefore the perpendicular or its perpendicular is another straight line.
Also has to be a straight line. Okay?
Yeah. That's what a perpendicular is.
No.
Yeah.
Yes, it is. Definition 10. I'll
do
get
we
it for
agree-
you if you want. I'll
do
put
we
it in the
agree
debate discussion.
That if we take an imaginary plumb line that could be just above the water in the tube, do we agree that the water surface inside the tube will be perpendicular to the vertical,
Absolutely.
being horizontal?
When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called a perpendicular to it. Definition 10, Book 1,
Okay.
Euclid, The Elements.
Okay. Do we also agree that when you put water inside a tube, it gets a little curved as it tries to?
You're talking about a meniscus which is inside the container.
Exactly.
This is formed. This is formed by friction on the side of the container, and nothing to do with
It's the capillary
containing
action.
water.
I'm
It
talking
is
about the
capillary
meniscus. Totally. I'm totally talking about the meniscus.
Yeah.
Okay. So, do we agree that? Do we agree that when putting a plumb line that could theoretically go through the water surface inside of the tube, do we agree that the plane that is perpendicular to the plumb line, that horizontal plane, is tangent to the meniscus?
No, it's going the wrong
What?
way, isn't it, you muppet?
The direction of the meniscus depends on the
Surface.
fluid inside the tube. If you've got a fluid like mercury, the meniscus will form a dome, and if you've got a fluid like water, the meniscus is concave. It forms
Indeed.
a bowl.
Indeed,
So
but
your hypothesis there, or your statement there, is just a load of old rubbish.
no, what I'm saying is that whatever you're putting, however, I'm touching my words. No matter the way you're holding your water level tool, the meniscus, be it the bottom of the meniscus or the top of the meniscus.
Hang on a minute.
You're
Right,
using that.
you are completely diverting. You're putting focus on a meniscus, which is completely irrelevant, because the plane is formed between one vial at one end of the water level and the vial at the opposite end. The meniscus has got absolutely nothing to do with the plane that is formed by a water level.
It does
You're
because
just
No,
poisoning the well with
you
this
can take the
meniscus.
same size
I'm
of the
not- I'm
meniscus
not
at each end and equalize it
I'm
out.
not
It makes no
poisoning the
difference.
well. I am trying to explain why I use the word tangent.
Because
So
you're
you're forming a
imagining a
tangent off a
curve.
meniscus.
The horizontal plane is tangent to the bottom meniscus.
Rubbish.
Oh, God.
Rubbish.
Sounds like a rather
Because
unpleasant disease.
if you've got mercury in your level,
Then
it
the
forms a
horizontal is
dome.
tangent to the summit of the dome formed by the mercury.
Obfuscation.
Rubbish.
Obfuscation. Come on.
Absolute rubbish.
You're a geometry teacher, and this is where you're
Allegedly.
going to, right? You're going
This guy's
to
a
the
teacher?
meniscus. He says he is, yes. A mathematics teacher. High school.
As well
technical
as physics
college.
and chemistry.
Oh, okay. Well, so this is
Oh,
where you're
really?
going with the physics of it. You go to a meniscus when establishing a horizontal plane with the tool a level.
Yes.
Okay. So,
What I'm saying is that if you consider there's a horizontal plane in the first tube and a horizontal plane in the second tube, independently of each other, there is a slight angle between the two. But
there's
the
an
is
angle.
so small.
What? Okay.
The
Well, so
angle is so
what's?
small
Can you
because of the
tell
short
me?
distance.
Can you tell me the angular change between the horizontals, and can you tell me which reference frame you would measure that angular change from, please?
Well, when using the horizontal plane of the first tube, you could determine the difference in angles with the horizontal plane of the second tube.
Okay. So you reckon
What?
you can measure an angle between a horizontal and another horizontal? Yeah, I think I could measure that as well. Do you know what I think I get as my angular change between the horizontal and the horizontal?
Except that, and that's what
We could go with
I
PhD,
wanted to
Tony,
go
and
with.
start making triangles, couldn't we?
That's what I wanted to go through.
What,
The
PhD Tony's triangles?
Is ridiculously small.
What is? Tony's triangles? Amazing.
The
Massive.
angle I'm talking
Massive.
about, the angle I'm talking about is ridiculously small.
Incomprehensible.
So you're going for a small angle.
No, let me finish, please.
No, I'm just clarifying what you said. You said that your angle is ridiculously small.
The angle between the two horizontal planes that are going in both tubes is ridiculously small, so we can simply ignore it and use the water level tool as a reference horizontal, using a plane that goes through both surfaces of both tubes. That's what I wanted to go to.
Okay, so over what distance are you talking? We're talking 1 foot, 100 foot, 1 mile, 100 miles?
How could I say it? There is a difference as soon as the distance isn't zero.
But you've just said that you can ignore the angular change between the two horizontals.
Because it is ridiculously small and it
Okay.
wouldn't show.
There are
wouldn't show
three
clearly.
angles.
Over 100 miles as well.
Well, over 100 miles, there will be a noticeable difference.
Okay, what would the difference be over 100 miles?
Good question. I'll start to you.
We should have just gone with 1 mile.
Oh, you know.
Mm,
I mean, because like we can all imagine a 1 mile stretch of canal, can't we?
This is true. Yeah, just keep it to 1 mile, Panda. Let's keep
okay.
it local, shall
Keep
we?
it, yeah,
let's keep it to 1 mile then.
yeah.
Yeah. Thanks,
Then-
Bev. Yeah, I was off.
Yeah, you were going
over
massive,
there,
right? Yeah.
Yeah, massive. I was going fucking massive.
Okay. I'm trying to estimate the angle difference.
Estimate.
No, I thought you were calculating.
Yeah, measuring it as well. And like,
I measure as well. Yeah.
I did say estimating. If I
No,
don't,
No, let's not have an
let-
estimation, because an estimation is just a guess.
yeah.
Yes, it's a guess, but then we
But
can
what's the
compare
point
it
in
with
just
measure.
guessing? Like we know, we say it's horizontal, right? There's no need for us to guess. We know geometrically what horizontal means. It's geometrically
what you're
described
saying-
as a perpendicular, which means it's a straight line.
Yes, we know. So if I follow
Whoa, we know. That sounded like you've got a bit of a song going. Have you been
if I-
talking to
if I
anybody?
follow you,
Pardon?
if I follow you,
On Twitter?
let's say I'm at one end of the canal, the 1 mile canal.
Yeah.
And let's say we put Bev at the other end of the canal.
Okay. Can we all get on the canal in a canoe?
Yeah, why not?
Brilliant.
Uh,
DP can get in a
go-
canoe in the middle.
I'll be in the
Just-
middle.
yeah, go on.
yeah.
Brilliant. Let's go. Let's
So-
do it.
Okay. So what if I follow what you're saying? It will mean that if every one of us has a water level in hand,
The same
Yeah.
water level,
the-
not a
the
water
exact-
level.
the-
We're all
let's say-
on
let's
the
say
same
the
water level,
exact same.
aren't we?
let's say the exact same, and even further, let's assume we are.
Can we
the
all get
exact
plumb bobs
same
out
size.
as well?
Let's assume we are the exact same size.
Now, hang on, you were just telling us what the angular difference is between plumb lines over a mile.
Was it plumb lines
Why-
he was talking about? No, he was talking about the
Well-
angular difference of the horizontal.
Horizontal, yeah, sorry, yeah. I got him confused with
We
Kozlowski.
might want to go soon. Liverpool's kicking off at R4.
Okay, where are we? I think I'm getting confused here.
You were trying to tell us the difference in angles between the horizontals over a mile
Oh,
of
yeah, right.
level water.
Oh, yeah, right.
You would remember you don't want to guess, you want to calculate.
Okay. No, I said estimation. but
Which
yes,
is a guess.
I said estimation, but what I
Which
meant
is a guess.
calculation. What I meant was calculation.
Oh, you're a maths teacher that gets confused between estimations and calculations. Ah,
Yeah, because actually I use
stroking my chin
very
right
often.
now.
I use very often the word estimate for my students in physics and chemistry, because at the start of any experiment they don't have any.
Well, this
information.
is getting away from the angle change in the horizontal
Yeah,
over a mile.
you're right.
So
You're right.
Yeah.
We're getting away. So 1 mile, you said. Yes, mile. Yeah. Okay, might take a little while. Or not actually.
So you're a maths teacher that's struggling with maths?
No, I'm not. I'm just find the right formula in order to not say something
He's
silly.
waiting for the team to come up with an answer. Right.
Uh-huh.
Ooh, I like that.
Ums and ums and
yeah.
ahs. Does it remind you of anybody?
Yeah.
Bev?
Yeah, it might have been
My good,
touching a
my
bit of
good
our stuff.
sirs, I would like to have an observation altitude in order to make the right calculation.
Well, let's say
Okay.
water level, shall we?
Yeah,
Water level?
you're on a
So zero.
we're on a canoe, right? On the thing, right? I'm going to have to go, DP, but I'm going to leave this. I'll have to leave it on. I'll have to stay in here. But the lads, we can jump
Okay.
in on the lads in the car when we get in the car. All right.
All right. Okay.
Do you agree if I take an altitude of 0?
You happy with that, Bev? An altitude of 0
Well, that's it. We're in our canoes on the canal. We're keeping this
on the canal.
practical. Everybody can understand
Okay.
what we're talking about.
Yeah.
Right, we'll be
Okay.
back in a minute.
Going through.
All right.
Just so we're clear, we are trying to determine the angle difference over a mile. Yes. Just
The
so
angle
I don't.
difference of
Okay, just so I don't mess up.
the angular difference of what over a mile?
The angular difference between a horizontal plane at one end and another horizontal plane at the other end.
Over the distance of a mile. Yep.
Do
Sounds
we
good.
agree? Okay. Okay, it will be at the air. So 1 mile. Not really that simple. For I always forget. It might take a little time. I have to do some conversions. I'm more used to SI units actually.
Take your time. After all, we wouldn't want you to rush and guess your result, would we?
Okay. Okay. So, oh, very small. No angles. Okay. I almost got it. Oh, that's awfully small. Okay, I think I got it.
You think you've got it?
So I recap. We said that there are two people at both ends of the canal, and both are at water level. Do we agree?
Yeah.
Yeah. And we wanted to calculate the difference of angles between one horizontal plane at one end and the other horizontal plane at the other end. That's okay?
Yeah.
Okay. So I finished calculating.
Hang on.
and,
This is assuming that you think that it is two separate horizontal planes,
yes, that is
right? Because
if,
I know it is just one continuous horizontal plane.
okay. That is assuming both planes aren't continuous, and assuming, of course, that the Earth is roughly a sphere.
Sorry.
Roughly. I said assuming.
No, hang on. We're just talking about geometry. We're not talking about the Earth. We're not talking about.
Yes, I know. But if you're using,
We're just talking about the surface of water.
Okay, I think I didn't understand quite well what we were talking about then.
Well, you've just brought a sphere, the same as you brought a tangent into it earlier from nowhere. You've
Yeah,
just brought a
I thought,
sphere into it from
I thought,
nowhere.
yes, I thought we were talking about, how do I say?
No. We're talking about the horizontal plane formed by the perpendicular to a
Oh,
vertical.
oh, sorry, I didn't understand. Oh my gosh. Okay, okay, I'm deeply sorry. I thought we were talking about the shape of the Earth. Oh, I'm so sorry.
No, we're talking about
I'm so
geometry.
sorry. Oh, so sorry. Oh, then forget everything I said. Of course, both will be exactly the same. Of
Right. So
course.
a
Oh,
plumb
I'm,
line at
I'm
one end
very
of the canal,
sorry.
the plumb line
I'm
at
very
one end
sorry.
of the canal will be on the same horizontal plane as a plumb line on a canal a mile
Yeah,
away.
yeah.
That water,
If you assume the
will be
water is flat,
horizontal.
yes. If you assume the water is flat, yes.
I'm not assuming anything. I'm talking about horizontal planes formed by a water level with the two ends a mile apart. I'm talking about the level of water forming a
Uh,
horizontal plane. I'm not talking about a flat anything apart
oh,
from the
okay.
horizontal
Well,
plane formed between two ends of a water level a mile apart.
oh, okay. So actually it goes with what I said. It actually depends on actually depends on the where the center of mass of the Earth under the water is
Why?
actually.
We're talking about a horizontal plane.
Yes,
The
tell me.
water level doesn't care about the shape of whatever is going on underneath it.
No, the shape, no, but the center of mass, yes,
No.
it does. Otherwise, you wouldn't have a 6 feet level difference
Right. The
in the
same.
water between both coasts of Canada.
The same way I am not assuming anything to do with the shape of anything, you are.
Yeah, yes, most probably.
No, most definitely, you are assuming. Now let's leave assumptions out of this.
Yeah,
We are just talking about geometry
yeah,
and
in
geometric, provable, tangible proofs.
yeah.
And a water level forms a horizontal plane.
Uh, yes, if you want to assume this, yes.
No, it's not an assumption. You were given the definition.
But
It's
no,
not an assumption.
no, the actual definition of level is what I said earlier.
No,
The
I'm talking
definition
about
of
the
level,
definition of a water level, which you read earlier, where it
yeah,
clearly states a horizontal plane.
yes, that is assumed between both ends of
There
the
is
tube.
no assumption. It is defined as forming a horizontal plane.
Are you talking about the tool or about the water in general?
Both of them. The water level forms a water level.
Yes, indeed. I do agree with what you just said, but I don't agree when someone says level equals horizontal.
It's in the definition of water level. You read it out yourself.
Yes, I did. But
So you disagree with the definition of the tool?
No, not of the tool.
No. Well, you kind of just did.
No, I'm not disagreeing with the definition of the tool. Actually, the tool is the water level device is actually a very good device to determine a horizontal plane of reference. I don't disagree with it. What I'm disagreeing
You
with
just did
is
disagree with it.
no, that's not what I'm disagreeing with. I'm trying to be more accurate. What I'm disagreeing with is that there is using the definition of the device and apply it to any water surface.
So you're disagreeing with the definition of the device can be applied to any water surface.
Yes.
So you're now saying that the water level doesn't form a water level.
No.
That's exactly what you've just said.
No, that's not what I'm saying. I repeat again, and I say it very clearly. I agree that the definition of the water level device is correct. It can
Right,
be
okay,
used.
let's stop there. Right.
It-
The water
Yes.
level device is a
Yes.
device that uses water to
Yes.
form a horizontal plane of reference, which is scalable, meaning it can be used at 6 inches, it can be used at 6 feet, it can be used at 60 feet, it can be
No.
used at 600 feet. This water level will always form a horizontal plane between the two ends. This is what a water level does.
No.
Yes.
That's where we are disagreeing, I think.
No, this is what the definition of the tool states that it does. It forms a horizontal plane of reference. You read the definition yourself.
Yes. What I'm disagreeing with is that if you get long distances, it doesn't it isn't correct anymore.
Right, so that isn't a horizontal plane anymore. That is not a plane on a horizontal. So you are disagreeing with the definition of the tool.
No.
Yes, you are.
What I'm disagreeing with is your interpretation of the definition.
No, you don't play that game. It's you that is disagreeing with the definition which you read out. Not once, but twice, I believe.
Okay. I'll try to be as clear as I can.
No, you are being plenty clear enough. You are saying that a water level at 6 inches forms a horizontal plane. At 6 feet, maybe a horizontal plane. At 60 feet, definitely not a horizontal plane. And yet the definition states that a water level forms a horizontal plane, and this is scalable. And you think you're a geometry teacher.
Okay, I think I got the problem sorted out. Okay. I reformulate what I said in order to be as correct as possible. Yes, the water level device definition is correct. If you're putting two tubes of water, whatever the distance between them is, you will have a horizontal plane between the two tubes.
Whatever distance.
Whatever distance. Okay,
And a horizontal plane is a straight line.
And a horizontal plane is indeed a straight line.
And the horizontal is perpendicular to the plumb.
Totally.
So at any point along this straight line, you will have a plumb.
Yes. No.
Yeah. Yes. Yes, you will.
Okay, I think we are getting through it. Okay. What I said is that you will have a horizontal plane between the two.
Hang on. So you will have a horizontal plane between the two ends of the water level, yeah?
Yes?
And this distance is scalable. Doesn't matter what the distance is, it will always have a horizontal plane.
Yes.
As
Horizontal
defined
Horizontal plane.
in the definition that you read out. So
Yes.
water forms a horizontal plane.
No.
Yes.
No.
This is what water level is doing. The water level uses water as to form the level.
No.
Yes.
The
So
water level device.
what is forming the level then? What is forming the level in the water level?
The water level device is
Answer my question. What is forming the level in the water level device?
nothing. The water level device isn't designed to form a level line. It is designed to form a horizontal plane of reference. You don't believe me? Don't believe me? Read the definition. Where in the definition is it
Right.
saying
Okay.
that
So the water level
device is used in order to define a level plane of reference? Nowhere.
we are
It is
talking
used to
about
define a
water.
horizontal plane.
Water forms a horizontal plane of reference.
Yes, between the two surfaces at both
Horizontal.
ends.
A horizontal is a straight line.
Yes.
The water forms a straight line.
No.
Yes, you have just
No.
agreed it does.
No.
The surface
What I said,
the surface of one vial is on a straight horizontal line with the surface of the next vial, the surface of the water in the next vial. This is a horizontal line formed between the two vials by the water surface. This
yes,
distance
but
is scalable. It works at 6 inches, it works at 6 feet, it works at 60 feet.
yes, but
Any distance
both water
forms a
surfaces,
horizontal plane of reference.
yes, horizontal, not level. Both surfaces in both vials aren't directly touching. Therefore, you can't say that what applies to the water level device can apply to a surface of water.
What?
The horizontal plane of reference
Now
is
say that
defined.
again. Say that again.
The horizontal plane of reference is defined between the two surfaces in the two vials. The two surfaces of the two vials aren't one surface. They are
One surface. It's the same body of water.
It's the same body of water, but it isn't the same surface.
Of course, it's the same surface, you muppet.
It's like saying the surface of a lake in a mountain is the same surface as the Pacific Ocean.
Rubbish. They're not connected. They're independent bodies of water. The two surfaces of the water in the vials are connected by a hose pipe that is filled with the same water. It's the same body of water.
It's the same body of water, but it isn't the same surface as.
It is the same surface. How can it not be the same surface if it's the same body of water?
Because they aren't exposed to the air in the same
Oh,
vial.
stop it. You're just being an idiot now.
Did you say the surface of a lake is the same as sea level?
No, that's what he was trying to say.
I
Yeah, I
check.
was like, you're way off.
We are
What's up,
realistic
dude?
now.
That's what he's trying to say. But he has said that the surface of water does form a horizontal plane. So
No, I
That's
never
right.
said
yes,
it.
you did.
You are saying I said it. I never said anything of it. I
Oh, you
said,
You
do.
just said it.
So,
You
I
do
repeat
realise this,
exactly what I said.
Panda.
I
You do
repeat,
realise this is being recorded, don't you?
I repeat exactly what I said.
You
What
do
I said
realise
is,
this is being recorded, don't you, Panda?
I don't care. In the single bit, I don't care a single bit. You can
Right.
record it.
You have said that water forms a horizontal plane
No, you
in the
said so.
water level, and the water level works on exactly the same physics as water.
I didn't say that. I
Yes,
said
you did.
that the water level device is used to establish a horizontal plane of reference
There you go.
between both vials.
Yep.
Yeah,
Good
at
deal.
6 inches,
Do
at
you
6
see?
feet, at 60 feet, at a mile, the horizontal
Yes,
plane between each water vial will be established.
I said a horizontal plane of reference. I never said a level plane of reference.
It does, and what? It is a horizontal plane of reference established by a water level.
It is simply a horizontal plane of reference.
Established
great.
by
Nothing
a
more.
water level. The
Yeah.
level
Good
of the
job.
water is establishing a horizontal plane of reference. Thank you very much.
Between both vials.
Exactly.
Great. Excellent.
Meaning, and we go back to geometry, that
Well, you've just given us exactly what we need. Thank you.
I would like to finish, nevertheless. Meaning that when we go back to geometry, in order to have a plane.
What do you mean? Hang on. Excuse me. What do you mean when we go back to geometry? We haven't left geometry.
Yeah. We were already there.
If you want a plane of reference, you
We've
need
already got one. You've just
2
given
points.
you've just given us a horizontal plane of reference formed by a water level.
Yes. You
And
need
each
2
end of the
points
water
of
level,
reference.
each end of the water level is a mile apart on a canal.
And that's the difference between the water level device and real water in a canal.
No. You are trying to say that the physics of water depends on whether it is in the canal or in the water level. That's rubbish.
No, I don't.
Yes,
No, I
you
don't.
do. Yes, you do.
No, I don't.
Water behaves exactly the same whether it's in the canal or it's in the vials.
Exactly. What you're not getting through is what I said is the water level device serves to establish a horizontal plane of different reference. Let's not even talk about a plane. It draws a line between the 2 vials.
Yeah, horizontal
That's
line.
even better. Yeah.
A straight line between the 2
A
vials.
straight horizontal line. Yes, we know.
Yes. But
And the water in the vials, in the water level, is exactly the same water as is in the canal. In actual fact, we will take the water from the canal and use it in the water level. How about that?
But
Go ahead, Panda. What is it? But what?
But the line is between 2 separate vials.
That are
There
connected.
is this. They aren't the 2 surfaces of the water aren't connected. They aren't one and the same surface.
It's the same body of water.
But it
They
isn't
are
one and the
connected.
same surface.
They are connected by a hose pipe. It is the same water.
Yes, but it isn't one and the same surface of water.
Doesn't matter.
It does actually.
It doesn't matter.
It does. You can't say the canal is the same as the water level device, especially because
Oh dear.
the
Do you think,
water at
right?
one end is
Do you,
connected directly.
do you think, right, that the Egyptians, they made the plain of Giza, right, and they used water to level the Giza plateau? Okay. Do you think they were questioning whether it's the same body of water that's forming the levels? I don't think so.
I don't think so too, but you're totally being irrelevant in this matter.
Panda,
No,
have you
What
ever
I'm
used the
saying,
water level?
okay,
no,
okay,
he's obviously never used any tools at all.
okay. I'll get through it one more time. The water level device uses two separate vials.
No, they're not separate. They're connected. They're connected by a hose pipe, and
Let me
guess what?
finish.
Water. It's the same
Let
body
me
of water
finish. You're being
in
very
each
impolite.
vial. It's the same body of water in each vial at each end of the water level. That's the way a water level works.
It is the same water, but I insist it isn't the same surface
And what?
as it isn't one and the same surface.
And what? And your point is what?
My point is you can't say the definition of the water level device applies to a large body of water with a single surface.
What does
You
that mean,
can't.
though? Why does that matter? I mean,
It
No,
does matter
there's significance.
because
No, this is your opinion.
no, it isn't my opinion.
Yeah,
It is
yes,
a
it is
fact
your opinion.
because you can't. You are. You are drawing a horizontal plane out of 2 points with the water level device.
That are on the same horizontal plane, just said.
Yeah. Okay. So what happens if you add a third point to your water level? Say you take a T at the half mile point, and you bring another arm off of the water level up the middle, and you make this part of your water level. So now your water level, instead of looking like a C laying on its back, looks like the capital letter E laying on its back.
It will be the same. You will have one plane that goes through vial 1, vial 2, one plane that goes through vial 2, vial 3, one plane that goes through vial 1, vial 3.
It'll be all the same plane. We've established this.
Well, no, it wouldn't be.
Hang on, if you've got the same plane going from vial 1 to vial 3 now, then why does adding a third plane in the center, how does this alter the plane that's already been formed? The water level will still form the same plane.
Not necessarily.
No, we've established that a water level forms a horizontal plane of reference. Just because
No,
you add a third point into
you
that
said
water
it.
level, the
You said it. I never agreed to it.
plane of reference is still formed. Therefore, that third point must adhere to that the horizontal plane of reference that's already been formed.
You said it. I never agreed to it.
No, you agreed to it. You said
No.
the 2 points form a horizontal plane of
Yes.
reference.
Yes.
So by adding the third point, it has to adhere to that already established plane of reference.
No, you don't know.
Yes, it does. It's a
No,
water
you
level.
don't know.
The water
No, you don't
level.
know.
The water level establishes a
Again,
level.
again, you are mixing up level and
No,
horizontal.
I'm not. It's the definition of the tool. The tool is a water level. It uses water to establish a horizontal plane of
Between
reference.
2 points.
And you add the third point here to that already established plane of reference. It
Why does it
must.
must? Why does it must? How do you know?
Well, what
It
do you
does.
think would happen? What do you think would happen then?
I don't know what will happen.
No, I tell you what. You've been wanting to guess at something since you turned up. So why don't you have a guess at what would happen?
I absolutely don't know.
Have a guess.
Honestly, I don't know.
Just have a guess. Have a wild stab in the dark.
Okay. If I had a guess, I'd say that you would form 3 different planes.
How can you form 3 different planes now? You had one plane between
Vial 1,
the
Vial 2,
no
Vial 1, Vial 2,
no
Vial 2, Vial 3, Vial 1, Vial 3.
you had one plane between vial 1 and what is now vial 3. You had one continuous plane.
Yeah.
So you had a center point, and now you've got 3 planes.
Yes, because you are adding a third surface, which is vial 2, in between. Therefore, you form 3 different planes. One between vial 1 and vial 2.
3 different planes.
Yes. You form 3 different planes, one between vial 1 and vial 2, one between vial 2 and vial 3.
And you're a
one
physics
between-
teacher?
Yes, I am.
Seriously?
Yes.
Define different planes.
What?
Cleary just asked you to define different
planes.
plane. You're roboting, Cleary. You might need to drop and come back again. Yeah, Cleary's just asked you to define different planes.
5.
Oh. Yo, mic check.
Hello?
Yo.
Is that you, Cleary?
No, it's me.
Oh, Bev, you sound like you're
Yo.
in the bottom of a box, mate.
Well, we're in a car.
Oh, right. Well,
So,
Panda's...
no
Panda, no, you're all right. We can hear you. Panda's just about to define his different planes that he's got now.
Yeah,
So-
we've been listening in. He's all over the place. I don't think he knows what he's meant to be saying.
I don't think he does.
You know these 3 different planes? You've got that one in the middle. That's a triangle you're making, right?
No, certainly not.
It's not. Well, it's 3 different planes. What sort of shape do you make with that?
Yes,
you do
indeed.
geometry, right?
Yes, you do make a triangle with it, but I don't see
Okay,
the
so
plane.
what are those dimensions that you imagine with this triangle that you've just made?
I don't know. What will be the length of the device?
Hang on, it's a mile, isn't it? We've already established it's a long.
I'll leave you with it. You're doing brilliant.
Okay, a mile, but then your triangle would be okay, let's go back to calculus. How the hell do you calculate that again? Okay. So let's say your device is following the canal.
That's a horizontal plane, isn't it? We've already established this, that points 1 and 2 are a horizontal plane, or points 1 and 3 were a horizontal plane. And now by adding a third point in the centre, so point 2, do you think this now forms 3 horizontal planes from one original horizontal plane?
Yes, simply because you added 1 point.
Hello?
Yeah, I'm here. I'm waiting for your explanation. I mean, simply just by saying simply because you added 1 point. What's that
Okay,
supposed to mean?
let's give the points names. Let's say we have A, B, and C. A being the first vial, B being the
Now, we've
vial
established
in the
this.
middle.
We've been calling them A, B, and C since the third one was introduced. So, okay.
Okay, let's go. Let's go. A, B, and C. You have one plane that goes through A and B.
Now, hang on. Let's go back to the beginning. You had
Yeah.
one plane that went from A
To C.
to C.
Yes, that makes one. One more going from A to B. That goes through A and B. And third one through B and C.
Oh, right. I see. So now you have a line that still goes from A to C.
Yes, it does.
And now you have vial B in the
Yeah.
center,
Yeah.
right? And you have a separate plane that
Yes.
goes from A to B and
the
from
third one
C
that
to
goes from
B.
C to B
Right.
or B to C, it's the same.
I've got you. Okay, right. So this triangle that's being formed,
Yeah.
does it go up the plum or does it
What
come
do,
down the plum
what
that is formed at that point?
what do you mean?
Well, you must have a vertical line
Yeah.
in the center, yeah. So the point of the water, the surface of the water in vial B, is it higher than the surface of the water in vial A and C, or is it lower than the surface of the water in A and C to form this triangle?
I'd say that if you take the height of the water in vial A as a reference.
No, hang on. The vials A and C are the same.
Oh, okay. You use the plane that goes to A and C as a reference.
Well, yeah.
Yeah.
Yeah, this is what I'm asking you. Is the water in vial C higher than the plane that's formed by A to C, or is the
Okay.
water in vial B lower than the plane
Okay.
that is formed by A to C?
Okay, I got it. Then I would say that in the vial B, the water surface is above the plane that goes through A and C, and that the height,
It's higher.
yeah, I would say it is higher, and that the height
By how
depends.
much?
It actually depends on the distance between A and C.
Well, it's half a mile. We've already established that it is a mile long water level, and the
Okay,
point B is at the halfway point. So this is half a mile.
then I'm going back to calculus. So we said 1 mile. Okay. Okay, back to calculus.
So you're calculating a difference and not measuring it? Is that what you're saying?
No,
Oh yeah. Well, we have
I'm
we
not
have been
there, so I'm
asking
calculating it.
we have been asking for measurements, but he doesn't seem to want to be able to give measurements. He always drops back to calculating. After all, this is the physical realm that you live in. You should be able to measure these things, not calculate them.
Oh, you can calculate it. You can
No,
measure
I'm
it.
not asking for a calculation. I'm asking for a measurement. But you keep wanting to drop back to calculus, to calculating these things.
Oh, I did. You can actually measure it, but if
How
you're
do you
using,
measure it?
how do you know you're correct if you haven't something to compare.
You take a direct measurement.
Mm,
What,
yes,
what,
we can, but actually I'm not very well equipped to do that. Sorry.
and how would you do that measurement if you were well equipped to do it? What equipment would you need to take that measurement?
A theodolite will be fine.
How you can measure that with a theodolite
Yeah, I think so.
over a half-mile distance?
Yeah, I think so.
Well, it's a good job you're not a surveyor then, isn't it?
Oh no, I'm not.
No, we just established that, so...
Okay. So okay. Hang on a minute. Okay, so in miles.
What is your formula, just as you're working it out? What is your formula for calculating the height difference?
I'm using again. I'm assuming that the water will follow a curved surface.
Why are you assuming the water follows a curved surface? We're talking about geometry.
But it
Why
is
do you keep dropping back to this assumption of a curved surface?
Because it was
All we are talking about is the geometry and the natural physics of water.
That's why the natural physics of water is to follow the curve of the earth.
No, it's not.
Well, we disagree about it seems.
Water level. The surface of water forms a level, a horizontal plane. Curvature has never been measured. You are assuming curvature to try and prove your point. So you are using an assumption to try and make a proof positive. That's not how it works, my friend.
Well, if it is I think I'm correct in using that assumption, because if it wasn't...
Hang on. How can you be correct in an assumption? You've just contradicted yourself.
I'll explain. Well, I think I'm correct in using that assumption.
No.
Because...
No, you cannot be correct in an assumption.
Okay. If I assume the sky is blue, am I incorrect?
No, you can see the sky is blue. That's not an assumption.
Okay. I am assuming a spherical form for the Earth And I am assuming that the water follows this curvature.
So everything
Because
you say from this point forward is an assumption.
yes, and I am
I
trying
thought
to
I
explain
thought you were a physics and maths teacher. Why are you assuming the outcome of the physics of water and geometry?
because the whole mathematics, the whole physics, the whole chemistry is based on unshakable assumptions.
Well, if they were checkable assumptions, they wouldn't be assumptions. They would be proven facts.
Wow, that was good.
Okay,
Say that again,
what?
man.
Okay,
The whole system is based on
if it,
assumptions.
Hang on.
if
Cleary's asking you a question. Can you just repeat your last statement?
my last statement that mathematics, physics, and chemistry are based on unshakable assumptions.
Uncheckable.
Yes,
Uncheckable assumptions. Mathematics,
yes,
physics, and geometry, did you say?
and
Are,
chemistry.
chemistry are based on uncheckable assumptions.
No,
And
not
you are,
no. Oh,
this is
yes,
what,
yes,
yeah,
yes,
uncheckable assumptions. This is what you just said.
yes,
And you claim to be a teacher?
yeah,
Really? You are
yeah.
teaching children uncheckable assumptions?
Yeah.
Oh my God, no wonder everything is so fucked.
Okay. Okay. Do you want me to show you my point? What my point is when I say
Well,
that?
just remember that everything you say from this point forward is only an assumption.
Yes.
Can I say one thing? You said you were establishing a horizontal plane, and then you said you had a curve.
Okay. Have you followed everything from the start?
Everything. Yes.
Yes. I did say I was establishing the water level device was used to establish a horizontal plane, but now that we have artificially added a third vial in the device.
No, it's not artificial. We just cut the hose and physically added a T junction and run another
Yes,
vial off of
I
that T
said
junction.
I
There's
said
nothing artificial.
yeah, I said artificial because you haven't actually, when we were talking, you didn't actually do that when we were talking.
So metaphoric is the
Eh,
word you're looking for.
Metaphoric. Okay. Then when we added third one, we can't say there is a single horizontal plane for sure anymore.
But we have established that a water level forms a horizontal plane of reference.
Yes, the
And
device.
this third vial is that water level. So it still
Yeah.
forms, and that third vial, the water level in that third vial, as I said to you before, must conform to the already established horizontal plane of reference that's established by points A and point C now. It must conform.
And what I'm saying is that it doesn't. And that you have no way to know for sure that it is the case.
Yes, we do.
How? I'm
We
interested.
we construct a mile-long water level. We cut it in half in the middle. We put a T junction in, and we put an extra vial in.
Okay. And what I'm then regarding the matter, I almost finished my calculations. Yeah, let's say that. Precision up to 6 numbers. 0.00. Oh, gosh, I hate the imperial system.
Well, why don't you measure it then? Just get a tape measure and run it
No,
from the
no, I'm
surface
not
of the
measuring.
water.
I thought it was well established that I'm not measuring anything.
No,
That
you can't. You can't measure anything. Is the
yes, I
terminology
can.
you're looking for? You can't measure it because it's a
No,
make believe.
no, I
You
didn't say
all you can do is calculate it.
that's not what I said. I can calculate it, but it can be measured actually.
It can't be
Uh,
measured literally.
with
Yeah,
feet.
exactly. Thank you.
Let's go with feet. No, not
You.
feet.
This
Inches.
is
Okay. So I finished the calculus, and so to answer your question, if, and I said if the
right.
your is
Let's just establish that everything you now say is an assumption.
okay, it is an assumption. Assuming the surface of the water in the canal follows the curve of the Earth. Also assuming that the Earth does have a curve. Okay?
Yeah, I'm good with it so far.
Then over a mile, if we put a third part of the device in the middle of the canal, then the difference in height between the plane that is formed passing through points A and C of the device, then the point B will be, I said will be, around 2 inches above the plane.
2 inches above the plane. Okay.
Yes.
So you're saying that the surface of the water in vial C would be 2 inches higher than the plane formed by the water levels of vials A and C. Yeah?
Yes, that's what I'm saying.
Right. Okay, let's work this backwards then. Let's go the other way. Okay.
Yeah.
What would happen
Mhm.
if the water in vials A and C forms a horizontal plane? Yeah?
Yeah.
And the water in vial B conforms to that plane.
Hmm. I'm not sure I understand what you're trying to say. Sorry. So,
How much more simple do you want me to make it for you? You've got a water level
yeah.
A to C. It forms a horizontal plane. You've
Yeah.
got vial B in the center, and the
Yeah.
water in that vial, the
Yeah.
surface of the water in that vial, conforms to the plane that is established by A and C.
Oh, so you mean that A, B, and C are aligned, correct?
Exactly.
Then that would mean that the water level is horizontal.
Okay, and if this water level is a horizontal level plane that has already been established off of the surface of the water in the canal,
Wait, you mean you did do the experiment?
this answer the question.
Uh,
You have a horizontal plane A, B, and C, a mile
aligned?
long water level.
Yes, and
This
assuming both.
horizontal plane has been established. The water level conforms to this horizontal plane.
Yeah.
The surface level of the water in the canal is
Yeah.
equidistant from the horizontal plane formed
Okay.
by the water
A, B,
level
and C. Okay.
over the distance of 1 mile.
Yeah. What is the question?
What happens if this is the case?
Then the whole surface of the water in the canal is indeed horizontal and level.
How can this happen on your ball?
I would say that there is something I don't know about that makes it appear so. Maybe. I don't know.
How can it be apparent when it's measured?
Well, are you referring to the Bedford level experiment?
No, I'm not referring to the Bedford level experiment at all. Can you just answer my question and stop trying to divert? How can it be apparent if it's measured?
Atmospheric refraction, maybe.
No,
I don't
it's
know.
measured. It is measured at points A, B, and C, and the water level, the surface of the canal water is equidistant from the water level.
Okay, I think
which
I
is a
know what's the
horizontal
problem.
plane, as we have already established.
Yes, but if you make your measures at point A, then point B, then point C, your reference changes.
What do you mean
doesn't
your
it?
reference changes?
I mean, you're making your measurements at point A. Let's say you make your measurements at point A. You will have, from point A, you will obtain a certain measurements for point A, point B, and point C when you are at point A. But if you go at point B, then it changes. I mean, your observations of point A and C.
Hang on, sorry, the battery went on my phone there. I didn't realise the charge was so low. I've just plugged into my iPad. So can you run that by me again? Because I missed what you were just saying.
Oh, no, sir. Okay, no problem. I don't. Okay. Okay, I'm saying this assuming I understood what you said. Okay.
Right. Okay. So repeat what I said. Right, to
Okay,
make
let's
sure that you understand what I said.
Okay, let's go. Oh, it was. Oh, it was. Oh, I had to repeat. Okay, okay. You're saying that you used a canal 1 mile long and measured at both ends and in the middle. Am I correct? Or
This is hypothetical. It's not. You've used the past tense, right? This is hypothetical. This is a what if question.
Okay, what if? Okay. Oh, okay. Okay, then okay. I assumed the experiment was made. Had been made.
Well, it could have been made. It doesn't really matter. But I am asking you as a hypothetical, because you know we established your hypothesis of what would happen if we entered a third vial at the center point of the water level. You have a hypothesis that the water in the level would be 2 inches higher than the plane formed by the other two. Now I'm asking you, we bring that down and the water conforms to that plane formed by the two ends of the water level, and that the water is measured from the top of the canal at each of the 3 points and is equidistant. So the distance from the water level in the canal to the water level surface at one end and in the center and at the other end, at the third point, is equidistant. So that horizontal plane that you have formed with your water level that has been established through points A, B, and C is then transferred to the horizontal nature of water at rest in the canal.
Okay.
And is equidistant. So now your water in your canal has been established as being an equidistant, parallel, if you like, horizontal plane from the
Yeah.
horizontal plane that has been established within the water level over the course of 1 mile.
Okay, I'm following you.
Okay. What would that mean for you about the nature of water?
For me, that will mean that, assuming again that we haven't ruled out or forgotten any factor that could be a source of error, that would
Yes.
mean that indeed the water of the canal is level and horizontal.
Okay.
Awesome.
Okay. So if the first mile of the water is level and horizontal,
Hmm.
then it must follow that a mile each way would be level and horizontal and conform to the same level
That
and
would be logical.
horizontal nature of the first mile measured.
That would be logical.
Okay, could you extend this over, say, 27 miles?
Why not? That
Why
would
not? Okay, so this now leads you to believe that there is no measurable curve in water if you establish that first mile there is no curve. If you establish that there is no curve within the first mile using a water level to establish your horizontal plane,
assuming we have ruled out any source of error, of course.
such as what? What would your source of error be?
Well, don't know. The instruments used not being correctly. What's the word?
Calibrated?
What?
Calibrated? Is that
Yes.
the word? Yes, calibrated.
The
Okay.
instrument not being totally accurately calibrated, or other factors like if we're outside, the influence of the atmosphere is not to be neglected, especially over long distances.
How do you mean the what with the atmosphere?
Well, atmospheric reflection, of course.
We're measuring. We're not doing anything visual. We're measuring. Remember, refraction only comes into play when you're playing with optics.
Yes, but okay. Well, the thing is, okay, I think I rounded up the problem. Okay. Okay, I think I got it. The thing is, we are indeed assuming. I don't know how to put it. The results of the measures that, but okay, hold on. I'm trying to put my thoughts in order.
Take your time. I'll be here. Don't worry.
Okay, I think I got it. What measurements are we talking about actually?
What do you mean? What measurements?
What kind of measures?
What kind of measures? Well, physical
Well,
ones made from
but
the surface of the water to the horizontal plane formed by the water level.
Yeah, but what kind of measures? I mean, are we measuring the length? Are we measuring?
What do you mean the length? The length is a mile. We've established this.
Yes, we established this, but what actually I'm not getting through what kind of measures you are doing in your experiment.
What kind of measures? What kind of measurements are we
Yes,
taking?
sorry, French education system.
Yeah, no worries. You are the perfect example of the French education system by the sounds of it so far.
Far from it. Far from it.
Yeah. The French
An example-
education sounds just as fucked as the English education system by the sound of it.
Oh, maybe I don't know about it, but I'm maybe I'm
Anyway,
a good
going
judge
back,
of it. Yes, let's go back. Let's go back. Let's go back.
going back to the water level. Let's not get into education systems and how they're
Okay.
screwed.
Okay. Hold on. Okay. I recap. So, if both the three vials are aligned. Oops. Hello? Hello?
Yeah, sorry, the Discord just kicked me out for some reason.
Okay.
Ugh,
I
I'm having
thought I
prob-
lost you.
Yeah, you did lose me, but not metaphorically, not literally.
Okay. So, let me do a quick recap. If the three vials are aligned on the water level device, and if it is measured that the surface of the canal is level in relation to the plane that is formed that goes through points A, B, and C, then it is correct to deduce that the surface of the water canal is horizontal and level. Am I correct?
Yeah, I'm fully behind you so far.
Okay. So, assuming this result is correct and that the first assumption is correct, we could extend the length to the length of the canal to whatever distance we want.
Yep.
For example, 27 miles, or let's
Or
say,
1,000 miles.
or let's be crazy, 100,000 miles. Then,
Well, let's not go that far, but we'll just say that if this is the case, then the surface of all water is a horizontal plane,
yes, then
level horizontal plane.
we can assume that if the first part is correct, then the last part is correct. That is, that water, whatever the length, whatever the surface, is horizontal and level.
That's good. That's
Okay,
good.
I think
So-
I got it true.
You think it would be true?
I don't think it will be true. I think
Oh, you don't think it would be true? Okay, so
no, that's not it. That if our premise is true, then
what? Sorry.
if
Yeah.
our premise,
Yeah.
if our premise is true, then I don't see any problem in considering that the conclusion is true. Using the reasoning with the reasoning we used right now, I don't see any problem in it. So yeah, if the premise is true, then through the reasoning we used, the conclusion is true.
Right. Okay.
Okay.
So we establish. First of all, we establish a horizontal plane, say with I don't know. Let's say we ask some surveyors. Okay.
Yeah.
We ask some surveyors to come along the side of a canal.
Yeah.
Right. And we ask the surveyors because they can form a horizontal plane using theodolites and their surveying equipment. This is what they do for a living.
Yeah.
They can form a millimeter accurate horizontal plane that gives us a datum, a reference point, right? This
Yes.
is a horizontal line formed from point A to point C with as many points in the middle as you want.
Yes.
And this line is a visual, optical. It's nothing to do with what's going on with the surface of the ground underneath it.
Yeah.
This, the surface of the ground underneath can do whatever it likes. It does not affect the horizontal level nature of the plane that is formed by these surveyors. Correct?
Absolutely.
Right. So they give us a datum at point A, B, and C.
Yeah.
We then run our water level, points A, B, and C, which is millimeter accurate,
Yeah.
and the top of the water level in our water level conforms to the datums established at points A, B, and C.
Yeah. So we have 3 datums. Okay.
With a horizontal plane of
Okay.
reference
Okay. We
and
have
a
3 datums.
water level that conforms to our horizontal plane of reference.
Yes. At each point, it conforms. Okay.
And then we transpose the measurement between the surface of the canal water and the datum at each point A, B, and C.
What measurement exactly?
The distance between the surface of the water in the canal and the datum point already established on our horizontal plane of reference.
Okay.
Now,
Okay.
if I understand you correctly,
Yeah.
then points A and C. Well, no, let's do it the other way around. Point B should be the measurement between the surface of the water and the datum point should be 2 inches less than points A and C.
Yes, but on one condition.
Hang on, there is no condition because you've already said that the water in the water level at point B would be 2 inches higher than points A and C. That was unconditional. So how come you're now
Oh,
putting a
yeah, excuse me.
condition?
No, excuse me.
You're now putting a condition on the distance measured
No,
to our datum points.
It's simply that I misunderstood what you say. So my answer would be yes.
There would be a 2 inch difference. There would be 2 inches less in the center. Yeah, just to clarify.
Wait, hang on. Do we agree that the 3 surveyors are making their datum lines or the datum at points A, B, and C independently?
Sorry? Say that again.
What?
Say that again. I didn't understand what you said.
Okay, do we agree that the 3 surveyors that are at points A, B, and C with their devices are making their datum independently from each other?
No. It's one surveyor making all the datum points at the same time.
Okay. Okay.
They are forming a horizontal plane of reference using surveying equipment.
Okay. Okay, they are making. Okay.
So
Okay,
it is one datum formed at one time, giving you one horizontal plane of reference, one level horizontal plane of reference.
Okay. Then, and is the horizontal plane of reference made through the device parallel to what we called earlier the AC line?
Sorry? Parallel to what? No, it's not parallel to anything. It's independent. I've told you this. It is. It's not. It doesn't care about the ground underneath
Okay.
it. It doesn't care about anything. It is an independently established horizontal line.
Okay, only the horizontal line is established according to the vertical of wherever the device is at. Do you agree?
The horizontal line is established
With the device
using
and
surveying
using
equipment.
surveying equipment. Okay, so it is linked to wherever the device is at. Okay.
This is a horizontal plane. It's
Yes, I understand completely. But the thing is, I recall I had a friend that used to be a surveyor before, and he explained to me that when the theodolite, let's say a theodolite for example, is calibrated, it is calibrated according to the local vertical.
it uses a spirit level. It uses a bubble.
Actually, his wasn't spirit level. It was
Well, the ones
electronic device,
the
but it's the
ones we
same
are
principle.
using have a spirit level, have a little circular bubble that
Okay.
you get into the circle to make sure it is level.
Okay. Okay. So yeah. Okay. So okay. I get it. So
You're running out of excuses.
no, I'm not running out of excuses.
Yeah, you are.
No, I'm not. I think I get it. So about what I said earlier, I would like to change my answer to your question
Which question? Which answer do you
because
want to change?
regarding the 2 inches difference in the measurement made surveyor.
Or you clipped out there. Say that again.
Sorry.
Regarding the 2-inch.
The 2 inches difference, not the one I calculated, but
Yeah,
the
but
one.
you calculated this. How can it be wrong? It's a
No,
mathematical calculation. So how can it be
no,
wrong? And why do you
that,
want to change it?
no, I don't want to change it, actually.
You just said you wanted to change your answer. And
Yes, but about the 2 inches difference measured, hypothetically
no.
measured by the
You didn't measure it. You calculated it.
Yes, I calculated it. But what I'm saying is regarding the question you had, the last question you asked me regarding 2 inches difference that would be measured by the surveyor if he stands at point B.
I never asked you about a difference measured by a surveyor. You are the one that
Yes,
came up. You are the one that came up with the difference, and it wasn't about
yes, I did.
a surveyed horizontal plane.
But when we
Your
talk,
difference was a hypothesis. It was an assumption. Remember, it was
yes,
nothing
I
to
do.
do with a measured horizontal plane that's been established.
But wasn't your last question was Wasn't your last question that if we ask a surveyor to make measurements at points A, B, and C along the canal? I thought your last question was would the surveyor at point B measure of difference in height of 2 inches compared with the
No.
measurements made
No,
at
that,
point
that
A and
wasn't
C?
that wasn't my question at all.
Oh, okay, I misunderstood.
How would a surveyor
Yeah,
get a 2-inch difference in a horizontal plane between points A and C? They wouldn't be a very good surveyor, would they? They wouldn't keep their job for very long, would they?
that is if it is horizontal.
No, a surveyor works on horizontal and vertical.
Yes, indeed.
So if you are asked to form a horizontal between points A and C, and you come
Yeah.
up with a point that is 2 inches higher in the center,
Yeah,
that's not a horizontal, is it?
no.
So you wouldn't be a very good surveyor, would you? I'll ask the
That is
question again. You wouldn't be a very good surveyor, would you?
no, indeed.
No, indeed.
But,
So,
but that's not the point.
and you wouldn't expect to keep your job very long, would you?
No, indeed.
Indeed.
Indeed, but I remember we said that the surveyor does establish a horizontal plane of reference at point A, at point B, and at point C.
No. Points A to C is a horizontal plane.
Yes,
Point B was added after the horizontal plane was already established.
yes. So it means that if the line between A and C is horizontal, then if point B is indeed along that line, then it means that there will be no height difference.
Yeah, and your point there is what?
Well, let's say actually the experiment will be
It's not an experiment. It's an observation. Let's not get ahead of ourselves.
I'm having a thought experiment here.
Oh, you're having a thought experiment. What's the
Okay.
independent variable?
I'm just exposing a thought experiment. Let's say we have, as we said since the beginning, a 1 mile long canal with a point at the center and 2 points at the extremities. We know for sure that the distance between point A and point C at both ends is 1 mile. That is undiscussed. Let's say we have 2 surveyors. No, not even that. Let's say we put simply sticks with markings on it that are equal length. We can even use the help of a surveyor in order to be sure that they are perfectly vertical.
Why are we bothered about vertical? We're talking about a horizontal plane. Why are you bringing vertical into it?
Well, let me go to the end and then we'll see where we're disagreeing. Let's say we have let's say we have those sticks that are, I don't know, 6 feet tall each. We make sure that every single stick is perfectly vertical. We put them at points A, B, and C. So we have 3 vertical sticks, 6 feet tall each, one at the beginning of the canal, one at the middle, and one at
Yeah,
the
I'm
end.
with you. I'm with you.
Okay, so we put markings on the sticks. We put, let's say, we'll put a mark. Let's say each feet we put a mark.
Each foot.
Each
So,
foot. Sorry,
right.
sorry. No,
So,
you're right. You're right to correct me. Each foot we put a marking. Then we decide arbitrarily to have a device that is just at one of the markings. Let's say the 4 feet markings. I'm totally speculating here.
you've got background noise. You've got a radio playing in the background, and it's drowning out what you're saying, and it's difficult enough to concentrate. And not having a go about your French accent,
Okay,
but it's
sorry.
difficult to concentrate.
Sorry.
And when the radio is drowning out what you're saying, it's really difficult to concentrate on what you're saying.
Okay, that will be better now. So, 3 sticks, 6 feet tall, markings each foot. We put a device to observe that is at 4 feet, 8. And we are looking straight to the 4 feet marking of the end stick. Let's say
What?
we are
The one that's a mile away.
the one that's a mile away.
Okay, this is optics. This is an optical test. We're not dealing with optics. We're dealing with a surveyed horizontal plane and a water level. Nothing to do with optics.
Then let me go to the end and you'll see. If then we look directly at the 4 feet marking.
No, we're not
at the
looking
end.
directly at anything.
No,
Optics plays games. We are not playing games.
Let me finish, please.
If this is pointless if it's an optical observation, because optics, as we all know, is ruined by atmospheric effects. You cannot use optics to determine anything.
Then what do you think surveying is?
Surveying is giving you a horizontal plane.
Yes.
This is what surveyors do for a living.
Yes, and you use that horizontal plane to measure things optically.
At close quarters.
Yes.
And you know how a surveyor. Do you know how a theodolite works? Do you know what stadia hairs are in the optics of say a theodolite? Do you know what stadia hairs do for the measurements?
What? Stadia?
Yes, stadia hairs in the optics of a theodolite. Do you know why they're there? Do you know what they do?
I don't think I know that.
Okay, well, go and research stadia hairs, and then come back to me with your criticism of surveying and the way surveying works.
How do you spell it?
Stadia hairs or stadia lines. Just research the optics of theodolites.
Stadya.
Yes, IA, yeah.
And haze, H-A-Y-S.
No, hairs, as in hair on your head.
Oh! Okay. The air was silent. Okay, Stadia Mark. Yes. Yes, yes, I know what you're talking about.
Okay, what do they do? Why are they there?
Uh-huh. So
Are you reading up on Google as we speak, or is it Wiki?
It's Wiki actually.
Okay, so open source, yeah, reliable. I would have thought a teacher would use
Always.
something a little bit more substantial than Wikipedia, but hey.
Horizontal, vertical. Signals a set of specific level support. Fixed integral ratio between different web readings.
When I said research, I didn't mean for you to kind of go into your own little bubble now and read up on it. It was something for you to do as a takeaway and then come back and see us when you've actually got an understanding, instead of an overview read from Wikipedia in about 30 seconds.
Okay, but before I go, I would like to share with you something I found that I think you might find interesting. If I ever find it again, of course.
Did you say a song?
No, I'm
Oh,
not.
I don't know what you said. I thought you were going to sing for us.
I'd like to share with us something, not something, something. I think.
Something.
Yeah, something. Yeah. Where are you putting it? Where can I find it? And how much interest will it be to me?
It's nothing but a photography made by a surveyor, I think, because it's a photography of a theodolite.
Yeah, who is that surveyor?
Where are you putting it?
Oh, I actually don't know. I found it on Twitter actually, so
Mm.
I don't know how reliable it is. But I found it interesting.
Posting it somewhere for us to see, or are you just going to talk about it?
No, I'm talking while I'm searching it actually.
Okay.
Okay.
I can guess who it is.
Yeah, I'm going to guess it's observation a mile across a lake that claims that the verticals are out.
I don't know the distance actually.
Yeah, Panda. When you look at a real surveyor, they're going up to maybe 100 meters between observations. They're not shooting miles across because
They're not going miles.
The actual observation is 48 meters.
48 meters
above water.
Above water.
Above water, yes.
What's the observation distance?
Oh, that I don't know.
Well, what's the point of sharing the picture then?
The thing is, actually, the person measured the angle difference between horizontal plane, and the horizon line.
How can they do that? The horizon is an apparent position. You can't measure an apparent position.
No, I don't know actually, but
The horizon isn't a physical place. You cannot measure the distance to something that is not physical. It is an apparition. It is an apparent position.
I didn't say it was a measurement of the distance.
You just said a measurement to the horizon.
Of a measurement of the angle between.
You can't measure anything at the horizon. A distance to it, an angle from it. It can't be done.
Yes, you can.
No,
It's
you
not a
can't.
tangible
It's an
point.
apparent position. There is no physical location for you to measure to or get an angle from.
Yes, you can. If you have a theodolite
No, you
that can make
can't.
a horizontal plane.
No, you can't.
Well, I'll show you, and you'll tell me what you think about it.
Well, I've got all I want from Mr. Panda. He's established that if the water level is, I'll just recap this, Panda, so that you can't say that you disagree at a later date. If we form our horizontal plane and our water level with 3 vials forms a horizontal plane that matches that original surveyed horizontal plane,
Yeah.
and the water measurement from each of the 3 points on our horizontal plane is the same to the surface of the water, you agree that the surface of the water in the canal conforms to the horizontal plane and this is scalable, yes?
I agree.
You agree. And this would happen at 1 mile, at 10 miles, 27 miles, 1,000 miles.
I agree.
And therefore the water of the surface level of water is one continuous horizontal level plane.
If the premise is true, yes, this is correct.
Okay.
Yeah, and Panda.
Cleary, Bev, anybody else?
Yeah, Panda. You said earlier the whole of pseudoscience uses unverifiable assumptions.
Yeah.
Yep. Cool.
I'm sorry, Query, you got your... What did you say?
Earlier, you said something like the whole of pseudoscience uses unverifiable assumptions.
Yes.
Yep. Like chemistry and
Yes.
I can't remember which ones you named specifically.
Oh, mathematics.
No, you said
Chemistry.
chemistry, physics, and maths. Yeah.
Mathematics. Yeah.
Yeah. Well, great. No further
Would you like
questions,
to-
Your Honor.
Would you like me to give you an example?
We've seen 1,000 of them, but I guess you could give us one more.
What?
We've seen many examples of people using unverifiable assumptions.
Yeah.
One more won't hurt, would it?
No, I guess not.
So
What?
come on in, Panda. Let's have your example.
Okay. 1 + 1 = 2.
Well, not if you have piles of sand, right?
That's totally unverifiable.
That's well, Right the Hand brought that up the other day. If I have one pile of sand and I have add another pile of sand,
On the
How many-
beach.
yeah, how many piles of sand do I have now?
What?
A pile of sand. You add another pile of sand to that pile of sand. How many piles of sand do you have?
Okay, sorry, I don't think I understand what you're
Right,
Okay.
all right.
Okay,
Try.
I'm-
I'm just going to do it another way, Cleary. Right, you're on a
I'm-
beach.
I'm
You're on a
very sorry,
beach,
guys.
Panda.
I'm not very used to discussion in English.
You're on a beach.
Yeah.
Beach is a mile long. You have a pile of
Yeah.
sand at one end and a pile of sand at the other.
Why? Yeah. Yeah.
How many piles of sand have you got?
Yeah. I don't know if that's going to help.
Oh. Okay, I see what you're doing here.
Okay, I've got a bucket of sand. I dump it on the beach, and I've got another bucket of sand, and I dump it on that
Okay.
pile. 1 +
Okay.
1 is what?
Okay. Now, what I'm saying is, okay, I think I understand your point, but I don't think you understood
My
mine.
point is math is not reality always. 1 + 1 doesn't always equal 2 in a scenario like that.
Yes, but actually, the equality 1 + 1 = 2 doesn't comes from nowhere. Actually, it's just a convention. That's what I meant by unverifiable claims. I mean, it would have been 1 + 1 = 12 if the early mathematicians decided so.
Yeah, I think we're getting out into la la land. Let's not go there.
That's what I'm saying. That's what I meant by unverifiable claims. It's the whole 1 + 1 = 2 is just a convention. Some everyone agreed to use that, but
Yeah.
it actually doesn't have any basis. And
Right.
that's
Or
what
if you
I
say I
call
want,
an unverifiable claim.
yeah, if you want to look at a light in the sky called Venus and assume it's the same size as the Earth, and then assume you know the distance to the sun based on that, that's all
Exactly.
assumptions, right?
Exactly.
You want to look at another light in the sky and pretend that it's X amount of light years away, that's another assumption. It's all assumptions. It's not science. It's just observe and declare.
Exactly.
Yeah.
I'm sorry, my good sirs. We'll have to leave you, unfortunately.
Great talk, man.
Well,
Thanks for coming by.
Yeah, Panda. Thanks for that.
Oh, thank you for welcoming me.
No,
Actually,
I've enjoyed our chat, and I'm glad we've established that if a horizontal line is formed, a horizontal plane is formed, then it is transferable through a water level to the surface of the canal.
yeah,
So all we need to do is establish that horizontal plane, then get the water level, see if it conforms to that horizontal plane, and
Yeah.
then transpose that to the surface of the canal.
Yeah.
Okay. Lovely job.
Okay. As I said, I will leave you, but before that, I have found my picture, so I can share it with you if you like.
A debate discussion. Can you see the debate discussion room?
Yeah.
Have you used Discord before? Yeah.
Yeah. I put it in there.
You put it in there already, yeah? Where did you?
There it is.
Oh, right, okay. And what is this supposed to show?
Optical distortions.
Yes, optical distortions, but that's
Yeah,
not the point. The
we've
point
seen that.
is on the left. It is what we observe on the left when the device is set at the horizontal, and in order for the line to touch the horizon line.
Oh, okay, hang on. I see that. You're 48 meters above water level already. So your horizontal line of sight.
It's not me. I don't know how to use that device.
Yeah, that's just somebody trying to infer something, right?
Yep.
Using optical distortions.
And they also. So what
the optical
would you?
distortion has nothing to do in there.
I don't understand. So what is it supposed to be showing, Panda?
That there is measurable angular difference between horizontal plane and the actual position of the horizon line.
Panda, let's back up now. Remember, we can't use our optical leveling device past 100 meters, right? Otherwise, if you're shooting off in the distance like this, you're going to have perspective compression, angular size reduction, and refraction effects from an observation height, which is already 48 meters above the water level. Okay.
Yes, indeed.
You know, you see all those optical distortions in your curved optics right there. You see things sinking in the distance due to atmospheric effects and then you
Yeah.
go over here on this other image and tilt your level down and pretend like that's what you should see. You're pushing your instrument way past its effective distance. And this is what people do when they try to infer Earth curvature. If you fall for this, you're a sucker, and I think you're too smart for that.
Well, actually, I know there are many sources of errors in this image.
Many
But
sources of what?
of error.
Yeah, I would like to know the
Error.
source of this.
Yeah.
I mean,
It's not.
I
This is
mean,
no way verifiable. I mean, you've got photographs of the sea and the horizon, and then
But
you've got separate photographs giving you digital readout, and they've just made a collage of 4 different photographs. This is no way verifiable.
Yeah.
I know.
They're
I
saying
know.
their zenith angle changes when they
I
tilt
know.
their instrument down. It's bad.
I know that isn't verifiable. I know. Actually, I'm not the one who made the collage.
That's what I said. Yeah, I would like to know who your source
I
was.
found
for
it. I found it like this on Twitter, like I said.
Can you give us the
Well-
link to that?
Oh,
Because I can
I
almost guess of who did that.
Why are you
thought that they don't
reposting? Why are you reposting stuff that's completely unverifiable and acting like it's a proof of something?
no,
I don't understand
no.
this. You've brought this here saying you would like us to have a look at this picture, and we've looked at
and
it
I
for 2
wanted-
minutes and picked it
and-
apart for exactly what it is. It's
And-
unverifiable collage made of 4 different photographs that you cannot say what each individual photograph is depicting.
Yeah, it's like you said,
And
Panda. It's
that's what-
unverifiable assumptions, pseudoscience.
And that's what I wanted to know. I wanted to know your opinion regarding such picture. And you gave it to me. So, thank you.
Can you just post the link that you got that image from? Because I would love to know where that came from. It's probably the same source where all of these types of inferences of curvature come from.
I absolutely don't remember because I have had this.
You've had it for a while. Okay, well then we'll
Yeah,
just
I've
have to,
had it for a while. I just,
yeah.
save as, and then going to do something else. So
Yeah.
I don't know. I could try to find it again if you wish.
No, it's
But,
okay. It's all right. It's
think
I mean, I'm not
can-
trying to be rude, but it's just a trash observation, and yeah, I think you understand what's going on
Yeah.
there.
Yeah. So I shared with you this image because I wanted to know what you thought about it, and now that you've said what you thought about it, I have my answer. So thank you.
Dan, do you agree with what we've said about it, or do you think
Yes.
this is a proof of something?
No, I agree that it is indeed not what we could call a reliable source.
Hey, Panda, I don't want to
Reliable.
pry. I don't want to pry into your personal business or anything, but do you teach high school physics or in college?
High school?
In high school, yeah. Okay.
Technical high school.
Mm-hmm. Oh, cool. Yep. Just curious. That's all.
Okay. And the specifics of French education system, the mathematics teacher is also the physics teacher and the chemistry teacher.
Yeah. Have you ever been up on the Eiffel Tower?
Yep.
You can
A
see
few
pretty
times.
far, right?
Yeah, kinda.
Yeah.
Can you see the sea from up there?
Oh no.
Uh-huh.
No, because actually Paris is kinda in how do I say?
Inland.
At the bottom of
Like a depression in the ground.
yes, Paris is in the depression in the ground and surrounded by hills,
Yeah.
South
by tall
London.
hills. So
Pretty damn
so
flat
you
right
can't
there.
you can't actually see very far.
Uh-huh.
And I don't get me started about the pollution.
About what?
The pollution, the air
Oh,
Oh,
pollution.
the pollution. Uh-huh. Yeah, yeah. Do you know
Nah,
there's a room there's a room at the top of the Eiffel Tower that you can stay in.
Yes.
Yeah,
Yes,
that's pretty mad.
It used to be the private apartments of Gustave Eiffel.
Yeah,
Wow.
yeah, the guy who made the tower. Yeah, he
Yeah.
used it. Yeah, he
Used
Instead of
to
going
Yeah.
up
have
and down every day, I guess he stayed up there.
yeah, yeah, and they rented it out for a little while, but I don't think they do it anymore, do they?
I don't think so. I
Hey,
don't
Panda,
think so, but I don't know. Yeah.
do you, I mean, you know, they built that around, what, 1880 or so. It was basically an observation tower, right?
Sorry,
Do you
can
know-
you repeat this?
Yeah, do you know why they built the Eiffel Tower back in about 1880? For observational purposes, pretty much?
I recall the tower was built for the Universal Exposition, but and it was supposed to be dismantled right after the expedition, but it was
Parisians fell in love with it, didn't they?
no,
And-
actually, they decided to let it as it is because it was an excellent transmitter for radio.
Yeah, so they converted it to a radio tower?
Yes, they transformed it in a radio tower, and it's a fun story. It was used during World War One as a mean to distract the Zeppelin pilots and make them think they were close to Paris, but in fact they were more north. They were
Oh, were they
way up-
shooting lights from it or something?
What?
I'm not sure how they used it to distract or disorient people.
They disoriented the Zeppelin pilots
Yeah,
how?
during World War One.
With what, lights or something?
No,
Shining lights?
no, through radio hacking actually.
Oh, they scrambled their signals with it. It was probably a big,
Yeah.
powerful radio
And-
tower. Yeah.
And what's the most fun story about it is that the German actually discovered that the Eiffel Tower was used to distract the pilots. And
Yeah.
then they said, okay, let's focus on the radio frequency from the Eiffel Tower, and it will guide us directly to Paris so we can drop our bombs.
So they back engineered it and turned it against the French.
Yeah, but
Yeah.
but the French learned about it, and then they said, okay, let's go full pirate. So they used the signal of the Eiffel Tower and put it at full volume in order to change the Eiffel Tower into a giant beacon for radio transmitters.
Hmm.
And then every Zeppelin went directly in direction of Paris. And then suddenly they decided to cut the power of the tower, of the Eiffel Tower, and they put full volume of the exact same frequency in Limoges, which is way up north of Paris.
Oh, that's cool.
So-
Yeah.
So the Zeppelin pilots suddenly said, what, the Eiffel Tower changed position suddenly? Oh well, let's follow the new position. And then the Zeppelin went directly into Limoges and they flew over and they said, damn, that's not Paris. And they crashed due to lack of fuel.
Oh, wow. Yeah. Yeah, they built a Blackpool Tower just after the Eiffel Tower.
Oh, I don't know. But actually, that's a very cool story.
Yeah. I just think it's interesting. You know, that time period right there.
Okay,
Hey.
okay, folks, I have to go. So thanks for letting me join. Thanks for the interesting discussion we had, and I hope you'll have a nice day.
Yeah, nice one, Panda. I really enjoyed this afternoon. Good chat.
See you next time.
It was nice for me too. See you
Yeah,
next time.
don't be afraid to come back. Don't be shy.
Oh, don't worry. Be
Cool.
happy.
Nice one. Cheers.
Ciao, mate.
Okay. Cheers.